So in this picture, you can clearly see that a car is moving down the slope, which is suddenly been braked at the rear wheels. Now due to this braking, a frictional force appears which acts at the rear wheel. So no frictional force actually acts on the front wheels, but it acts on the rear wheels only. Now at this moment the whole car is in equilibrium, which means that this Fr balances this force, that is W sin theta plus W by G into alpha. Now this is the center of gravity of the car, and through which the whole weight of the vehicle acts through downwards, vertically downwards. And there are two components of this W, that is, one is W cos theta, another is W sin theta. Now in this force, this is the component of this W, and this is the inertia force, that is W by G into alpha, and alpha, it is the deceleration or the retardation of the vehicle. Now Ra and Rb, it is the reaction force on the front wheels and the rear wheels respectively, and B, it is the wheelbase of the vehicle, that is the distance between the centers of the front and rear wheels, and the CG is above H height above the slope, and X, it is the distance of the CG, parallel distance of the CG from the rear axle. So this is the rear axle, and X is the distance of the CG from the rear axle. Okay. Okay, now let us see what are the equations we can form through this from this figure. Now the first equation it says is W cos theta is equals to Ra plus Rb. Clearly you can see here in this picture that W cos theta, which acts normally downwards on the slope, is actually balancing out this Ra plus Rb. So that's our first equation. Now the second equation is this force that I previously told you, that W sin theta plus W by G into alpha. This whole summation that tries to pull the vehicle downwards along the slope is balanced out by this frictional force Fr. So this thing is equals to Fr. Fr is nothing but mu times Rb. Okay, mu is the coefficient of friction between the road and the rear wheels tires. So Fr is equals to this thing. Now if we take moment about A, we get we are taking this point A and we are trying to get the moment about A. So Rb times B, so this is the wheelbase and this is Rb. So Rb times B tries to tilt the vehicle anti-clockwise, and W cos theta into B minus X, so this is B and minus X, so this length is X, B minus X. Now W cos theta into B minus X acts clockwise, so hence it has a negative sign. Plus there is this force which is actually acting like this way, again anti-clockwise, so it will be plus, that is W sin theta plus W by G into alpha into H is goes to 0. Now you can see that Rb into B minus W into B minus X into cos theta plus mu Rb into H. Now I have, instead of this term, from here I put here mu into Rb, so that's how I got mu Rb into H. Now if we take Rb common, you get B plus mu H, B plus mu H, and this term I send it on the other side of the equals to sign, that is W, that becomes W into B minus X into cos theta. So Rb is equals to this thing divided by B plus mu H. So I've got Rb. Now I just will from equation 1 I will put the value of Rb there. So I will get W minus Rb, that is W cos theta. Sorry, there will be a W cos theta. That is, so it will be W cos theta minus Rb, and if we put the value of Rb, we will get this term. Taking the W and cos theta common, we will get this term. Now when we get the two terms, now it's time to get the value from equation 2. We can get W sin theta plus W into alpha by G is equals to this term. Now from equation 2 you can see that instead of Rb, I will put the value of Rb there, and we can get the value of alpha by G. Thus, we will get alpha by g equals to mu into b minus x into cos theta divided by b plus mu h minus sin theta. If you have any doubt, you can pause the video and check the equations. So here you can see the complete result. Here I've used f by g, which can also be written as alpha by g. F is basically the retardation of the vehicle, and I will put the whole note in the description. Go check it out in the description. If you have any question, comment down below, and also do subscribe.